recently, and I know other people have had trouble, is that sometimes when you post something, people start commenting inappropriate links or bad things, or sometimes there's some suspicious activity on a website or something. And it can be hard if you have a big website or facility to check every single little one, comment and everything, and to catch it in time, especially if you have limited computing power. And then how do you prioritize? Do you prioritize the big scale people or the small scale people? Prioritizing the big scale websites, yes, they get more likely to receive comments, but there's some problems that if someone is a small time creator or something and it's trying to start up, it can make them a lot harder for them to start up because they have to take more of their personal time to curate and manage it. And when a big time creator, there might be some inappropriate comments, but thousands of comments might be totally appropriate. So it might be percentage-wise a lot smaller than a small scale person being targeted. Beyond that, so it's unfair advantage for the big time people. Beyond that, it now means that maybe algorithms look for small time creators to spam or bot because those are the ones being targeted. So how do you balance computation power with all this stuff? Well, I have an idea. Is that first, instead of running all the checks on the server, and this is also to make stuff speedy, you send it out to a person, and that person that is looking at your stuff, let's say A, on their computer they run the checks because you send out the algorithm to check it on their computer and they run it on the side. This will slightly slow down the computer, but you can make it so it's not a significant, and it will slow down the first upload, but the second or third upload after it's checked, it's running fast again. And this means that also that if no one's paying attention to that site, or that site's not getting a lot of traffic, you don't waste time on it. You waste about as time as that site is getting traffic on, and actually a little less, because once you find it. Now to make this algorithm a little faster and better, let's say two people have to do it, A and B. Well, now B can run some of the checks, and A can run some of the checks, and they can tell the middle server, which I'm going to put big S, what they've already checked or not. And if it can see if there's high traffic, the middle server can also be checking, but it has a limited space, so it can't check everything quickly, but it's going to give some places more. It might actually check smaller ones faster because those ones have a less likely. To make the system even faster is if people can flag reports, then it can, if you have a humanistic where people flag reports, then it can run even faster, and it can look at those flagged reports and give them priority for extra checks and stuff like that. So that gives an even better computational resource to minimize that. To make it even faster for checks is that if your Wi-Fi is good enough, or if there is not too much lag or anything, you can have some computers in the background just running the algorithm and checking instead of your server for stuff if it's appropriate or not. And maybe it could even be a paid service, maybe not, but other people be checking to filter out. Now, the problem with the most sophisticated filters is that they are not the best because they cannot cluster or stuff. And by that I mean is the most sophisticated best algorithms are very large, chunky algorithms. And by large, chunky, I mean it's just one giant network that checks for every type of bad thing would be the best. One giant network, and this checks for any type of inappropriate comment, whether it's ones to links to hack you, inappropriate sexual pornography, inappropriate language-wise, everything is the most efficient. Then you can subdivide it, but if you subdivide a task, you might not subdivide the best, because because maybe if you subdivide it by links, you can subdivide by inappropriate links to inappropriate actual comments written. But maybe that's not the best subdivision, because that's not how the computer thinks, or the links could be more useful if they both fell under the bad, if it's more was categorized by what type of material is inappropriate, language or sexual imagery or whatever. Or maybe it was better from something else that you group it by, not by type, but also by just, maybe it's first best to look at certain language, so you look for certain keywords of language, then you look for other ways it's inappropriate, or something like that. Or it could be very complex, like if so, say into this. Well, this is how I would do it, and that is a type of self-organizing network. So here you have this network that trains. So I'm going to bring up a neural network. Neural network. And I'm going to show you how the self-organizing neural network works. Network deep. So here is a so-called deep neural network. But imagine that but if I want to explain it so people that are not looking at it, first there is a layer of neurons or nodes, and these each take in some of the information. Each node takes in a little bit of information. Maybe it's a pixel, maybe it's a letter, maybe it's a character, maybe it's even part of them. Then they connect to little nodes in a layer beneath them all over the place, and nodes in a layer beneath them, and so on for a few layers. Then they go to the output, which is just like the final one that says yes or no. So then for this yes or no, you can start to and how it works is that each layer does a little computation, and the next layer does a little computation and messes up your data, like looks at different relationships between different characters or text, until it figures out a bigger relationship that actually tells you the answer. It's you can kind of think there's many operations that you can break down to simpler ones. Training it to figure out how to break it into a simple calculation layer by layer, that's difficult. But like, how do we do addition? Well, first you add up some digits, then you add up some other digits, then you add up some other digits, like 13 plus 12. Well, first I might add up 10 plus 10, 20, and 3 plus 2, 5, and then I add 20 plus 5 to get 25. Something like that is how a neural network might work, but it might work in a different way. It might first add up, instead of 13 plus 2, then plus 10, or some other strange combination that we don't know. But anyways, the neural network figures out some way to compute what's bad or good at the very end when it reduces it just to one answer. But in the middle, it's doing all these complex calculations. The trick to self-organizing that I'm about to explain is that instead, I take this middle layer, and this middle layer gives me a bunch. This middle layer is not my yes or no answer. It still can have like 10 or 20 or more parameters that give me numbers like 1, 2, 3, 4, 5, or 6, 9, 8, 10, a bunch of numbers. But these bunch of numbers, I can then take these numbers and cluster. Now, if I cluster these numbers, I can then have something I can then see how the data is distributed. So, for example, maybe certain of the ones are clustered around 1, 2. And some of them are clustered around, and then there's going to be a cluster of 1, 3, 1, 4, and 1, 5. So most of these pairs of numbers have just 1 in front. But then there's something way far away on my graph that is my next amount of data that's just 1, 10, 1. Sorry, the first number should be 10, 10, 11, and it's just 10, 12, and so on, or 10, 13. These numbers are pairs of numbers that are very far apart from other number, and you can kind of, if I was to make a graph of this with just 2 dimensions, with just 2 parameters, the graph would look like all my data is either in a blob here in this neural network or a blob over here. 2 separate far apart blobs. There might be 50 far apart blobs or more, but each blob contains a lot of the data. Now, it also might not be in 2 dimensions, it might be 3 dimensions, 4 dimensions, 5 dimensions. But I'm taking it in this neural network that's very specific, much more upfront. This means that when I put in the data to first review it, I don't have to run the full neural network. What I instead do is a couple times I run the full neural network and I train it to recognize good and bad. But then I realize that then I train it to run like half the neural network. And it's or a third of the neural network. So let's just say to the first layer. This gives me a cluster of stuff that's similar, and that I know it can be used to compute whether it's good or bad, because this number is used on the bigger neural network. It's just I'm cutting it a step early. So then I put this in this clustering algorithm, and clustering algorithms can be amazingly fast. And then I say, hey, if it belongs to this cluster, then please send it to this neural network train. And I can decide as many clusters there are to create that many neural networks. And then that neural network only checks for data in that cluster, which might be a cluster it only checks for inappropriate content or this and that. Inappropriate content sexually or non-sexually, or cluster checks it this and in other ways. The other thing I can do with clustering is I can cluster a couple different neurons and see if their values are always distinct from other values. Maybe the numbers I get in these 2 ones always are different, are completely independent than the top 2 neurons in this layer, are completely independent of the bottom 2 neurons. Then I could theoretically do a bunch of calculations just with the top 2 neurons, or part of it, and I can use that to reduce the calculation time by first running the check on that type. And then I can, the problem with that one is that it might later on be dependent below about what's going on. So that's better to do near the very end. So we have these ways of clustering, which can lead to fewer parameters and a faster check on specific ones. And if it's in a group, the algorithm might become even faster, because those small layers might learn to, because they're not looking at everything, they might learn to look faster to find certain patterns. The other thing we can do is we can try to make as many of these pathways as independent as possible. And therefore we have different feature detections. So first we might try to make this have built in detect sense more of certain types of information and faster. So what I mean by that is maybe I try to make it first have this algorithm have more of a language detection feature and more of an image detection feature separate, or a inappropriate link feature detector and a non-inappropriate link feature. So when I cluster either by neurons within the neurons, like top ones or bottom ones, I can see it faster. Or if I cluster by type of inappropriate content, it finds it faster. How would I do this? Well, the way to do this would be to make it so that, well, there's a bunch of ways that people have worked on. One is that I can not connect everything to everything else in each layer, so then I have more likely to have ones that are different. Other ones is I can have functions that round or only trigger when there's a certain sensitivity from other ones, like neurons, there's an action potential. That way, unless it's a really big signal, it acts separate from other ones. And there's other architectures, and there's something called transformers that's fancy, which I look at. But I think that's a little bit beyond the scope of this video with time. Now, once I have all these little small algorithms, I actually don't have to run it through the big algorithm. Because each of these small algorithms, I can just put it through A through B. I can just copy the first two layers or so. Just run the first layers once, get that data, and then I just don't have to put it through the cluster algorithm. I can just send it to each of these small ones for them to check even a broader range. And the advantage of not putting the data clustered, just sending that manipulated data outwards and not checking what cluster belongs to, is that if the clusters are not perfect, it can still look at it and figure out if it has multiple types. So like some stuff might have multiple types of inappropriate content. So let's say this was inappropriate content type 1, this is type 2. There might be some data streams that are both types, and it might be hard for it to cluster, and it might end up in the middle instead, not belonging to any cluster or something. Or that maybe there's some data set that just straight out here, because the data sets are not complete, and cluster sets often not fully complete. Like maybe my data is here and here, so I get the clusters here and here, but there's actually a lot of data that exist in between that are not clearly defined clusters, just because I just didn't have data in that, but my neural network can still interpret that. So by that, I expand that, and it also stops overfitting and stuff like that. Now, the last idea I have to make this whole system better is that people can also put different blocking settings. And we always see this, and we can say like, oh yeah, I want only content. I really want you to check thoroughly. And this can be a channel saying it. I can say that I'm okay, check for this type of content mostly for X, because I'm more bothered by X content, or I know more of X inappropriate content on my channel or something. I can also have users do that, and they will first check for certain type of content inappropriate or not, or they might say they're okay with slower service more or with better content, or they want faster service that's less filtered. And this doesn't only work for like comments or stuff. This can also be work for checking hacking links or other things, or seeing if sources are verifiable or good. Well, thank you very much. Hope you found this interesting. Please like and subscribe, leave a comment behind. It really helps the channel out very much. Thank you. Goodbye.